We're around electricity literally all the time, but it has a couple of secret powers that honestly shape our entire world. So today, we're going to pull back the curtain on the magnetic and heating effects of electric current. So let's start this off at a science fair. Picture this. A student, Sumana, has a simple iron nail wrapped in wire hooked up to a battery. She closes the circuit, and boom, the nail suddenly acts like a magnet, picking up paper clips. She opens the circuit, and they just fall right off. What is going on here? This observation brings up a fantastic question, one that actually stumped scientists for a long, long time. What's the hidden connection between electricity and magnetism? How can one just create the other, seemingly out of thin air? To solve this mystery, we have to uncover electricity's first secret power, its magnetic effect. Turns out, an invisible force field just springs into existence whenever a current is flowing. And believe it or not, this huge discovery happened completely by accident. It's 1820, and a professor named Hans Christian Oersted is in the middle of a lecture. He notices that every single time he switches on an electric circuit, the needle on a nearby compass twitches. He had just stumbled onto one of the most fundamental connections in all of physics. Now, what's really cool is that you can actually see this for yourself. Seriously, if you just run a current through a wire and hold it over a compass, you'll see that needle move, just like Ørsted did. It's proof that the electric current is generating its own magnetic force, and it's strong enough to mess with the compass. So that invisible area of influence, we call that a magnetic field. It's like a bubble of force that surrounds the wire, and it only exists when the electricity is flowing. Okay, so let's get back to that nail at the science fair. When you take that wire and wrap it into a coil, you're basically concentrating that magnetic field. And that's how you create an electromagnet, a magnet that you can switch on and off. The incredible thing is that all magnetism is basically caused by moving charges. The coil just helps us organize it to make it super powerful. And here's the really crucial part. We are in complete control of these temporary magnets. You want a stronger magnet? Easy. Add more loops to the coil. Or you can just ramp up the electric current by adding another battery. Oh, and if you want a real power boost, stick a piece of iron, like say a nail, right in the middle of the coil. That strengthens the magnetic field like you wouldn't believe. And this simple idea gets scaled up for massive industrial jobs. In scrapyards, those giant cranes use huge electromagnets. They can lift an entire car just by turning the current on, and then drop it wherever they want by simply flicking a switch to turn it off. But if you're playing around with this, you might notice that the wires start to get a little warm. Well, that's not just a side effect. It's actually electricity's second secret power. Yep, that warmth you feel is electricity's other hidden trick, the heating effect. And it's the very same principle that powers some of the most common gadgets we have in our homes. You see, as electricity flows through a wire, it doesn't get a completely free ride. It runs into resistance. You can think of it kind of like friction. And that struggle converts some of the electrical energy directly into heat. You use this every single day. Your toaster, your hairdryer, your electric kettle, they all have a special coil inside with really high resistance. It's called a heating element, and it's designed specifically to get super hot when you run a current through it. Okay, so we've seen what electricity does. It makes magnets, it creates heat, but in a portable device, like a flashlight or your phone, where is that electricity even coming from in the first place? Well, the answer starts with a pretty bizarre discovery back in the 1700s. A guy named Luigi Galvani saw a dead frog's leg twitch when he touched it with two different kinds of metal. He thought he'd found some kind of animal electricity. But another scientist, Alessandro Volta, had a better idea. He guessed the electricity was actually coming from a chemical reaction between the metals themselves, not the frog. Volta's hunch led him to create the very first battery, the voltaic cell. It used metal plates dipped in a liquid. Now, it was a massive breakthrough, but not exactly practical. You couldn't carry it around. The real game changer was the dry cell, which swapped that spillable liquid for a moist paste, and that gave us the convenient portable AA and AAA batteries that we use for everything today. But of course, that evolution from a wet jar to a small, compact cylinder didn't stop there. The search for better, more portable power is driving some amazing innovation right now. We've moved on to the rechargeable lithium-ion batteries that power our phones and electric cars. But the next big leap is something called solid-state batteries. They promise to be way safer, charge much faster, and last a lot longer, potentially revolutionizing everything from our gadgets to the entire energy grid. So, let's just do a quick recap. We've seen how electric current is a double agent, right? It creates magnetic fields and it creates heat. And we've seen how the chemical reactions inside batteries, from Volta's very first cell all the way to the solid-state tech of tomorrow, are what give us all that power on the go. We've seen how these fundamental forces, electricity, magnetism, chemistry, are all tangled together in these really fascinating ways. It just makes you wonder, doesn't it? What other profound connection is just out there, waiting for the next accidental discovery? Something to think about. Stay curious.